recording. And I'm gonna kick off the broadcast right now.
The broadcast is now starting. All attendees are in listen-only mode.
Good evening, good morning, good afternoon, depending on which time zone you're in. This is Frank Büchsel with the vBrownBag, and today I have Bjorn Brundert and Michael Gasch giving us an introduction to containers and container cluster management. And as usual, just a bit of heads up before we start. If you have any questions throughout the presentation, you can either tweet the vBrownBag Twitter handle, use the hashtag vBrownBag, or simply use the built-in chat in GoToMeeting here. And with that, I'll give it over to Bjorn and to Michael to give a short introduction to themselves and to actually kick off the content.
Bjorn, you go first.
Okay, hi everybody. So my name is Bjorn. I'm a principal TAM, so technical account manager at VMware. I have been working with VMware for over 7 years now, working with various large customers on their journey to SDDC and hybrid cloud, with a special focus on cloud native applications, DevOps, and all things around that.
Cool. My name is Michael Gasch. I'm a platform architect at VMware, working in the global customer success organization, and my focus is mainly around Kubernetes on vSphere.
Perfect. Thank you, guys. And
Awesome.
yeah, I can see the slides, so feel free to take it away.
Let's see if the joint clicking actually works. So I'm taking, yep, it works. Awesome. At least I thought it works. Okay. Sorry for that. It's a little distributed system here, and distributed systems are hard. Just briefly on quick disclaimer, right? So we might cover topics in this presentation that have not been shared publicly, even though we don't expect that to happen. So please make sure to read the disclaimer if you're on the recording and in the session. But actually, we want to start right with the agenda, right? So we'll briefly cover how we got here, because that's a very important topic to cover when you talk about containers and the motivation for cloud native applications and container orchestration. So why is it actually happening? Because just from a technical perspective, it's one of the many iterations in IT, and you always should ask yourself why you're actually doing this. Then we jump into what is a container, then go into the orchestration piece of it, and also meet Kubernetes for the first time. We'll talk about VMware strategy and solutions very quickly. One specific topic that's of high importance to Michael and myself is the role of the platform engineer. That's something we're going to introduce. And last but not least, give a quick preview to the second part of the brown bag, which will happen next week, and that will focus on deep dive on Kubernetes. So how we got there. So I hope most of you have seen the keynotes from VMworld, and actually I want to start with a little step back from the technology topics and talk about digital transformation overall, right? So Elastic Sky Pizza, the virtual company that was introduced at VMworld in Las Vegas, is actually a pizza company, a pizza delivery company that is perhaps the biggest name in pizza delivery over the past decade. But it's facing massive competitive gains from their major competitor, Shredder Pizza, which is now using robots to actually build pizza, right, or create the pizza. So they had a data breach, millions of credit card numbers were exposed, and there is sort of a broken culture in core technology topics. So the IT operations and develop departments are basically out of sync. So they're no longer sharing the same principles and making life very easy. So they in this virtual company, there was a project called Leonardo that was initiated to stabilize and expand the environments, to manage the applications across multiple clouds, find the right resources for the right applications, and then focus on actually bringing Project Leonardo to life, and then optimize it over the operational period afterwards, as well as discuss additional ideas how to leverage IT inside the company. And this overall is a very important topic if you look at the IT transformation, digital transformation overall, right? I guess everybody that works in IT is in a company that is somehow struggling to keep up with the daily operations, but also to innovate, right? And the role of IT is changing to enable that kind of innovation. So Elastic Sky Pizza is a great example. If you read the Phoenix project, for example, you remember Parts Unlimited, the company from that. It's very similar. And I think everybody has their own story to tell. And remember, this is very important because in the end, we're doing IT for a bigger reason, right? For a business that's actually relying on this IT. So we're not doing it just for the fun of it. You should always ask yourself why you're doing certain things and why you're making certain technology decisions, and does that actually help the company, right? So with that, let's jump into a quick example, right? So not a long time ago, it was actually this way that users were just saying, I want apps, and your developers were just requesting access to virtual machines to do some coding, right? So nothing special. This is how we got there, where we are right now over the past couple of years, right? But life is changing, right? So the demand of the users is still apps, but they want more apps. They want new features, and the whole business to consumer relation is changing quite a bit, right? So every user and every customer and every company, even a pizza company, expects the business that it's dealing with to be a lot more flexible, to work on a lot more consumer-oriented activities, right? So the developer is no longer just asking for access to virtual machines because the demand to the developers is increasing massively. So what they want are APIs, they want DevOps, they want containers, but they don't really want to control the infrastructure anymore, right? So they look for alternatives to virtual machines, to just naked virtual machines to get their job done, right? So what they look for is stuff like native services on leading public clouds, for example, or leverage technologies like containers or any other stuff that actually helps them get their job done, right? So if you look at it from just from a relationship perspective, so as I mentioned, the business is actually working with the application developers, and the application developers are interfacing with the infrastructure, right? So what we call digital transformation is mainly happening in business and applications, right? So business will dictate changes to the applications and transform them to make them more user-centric, agile, integrated in a better marketplace or with partners. And on the other hand, we have a lot of focus on DevOps, which is mainly how do applications and infrastructure people work together and get their stuff done. And the question is, who is able to get through the cycle of building new apps or new features into existing apps, who is able to deploy them as fast as possible, monitor them, use the feedback that is provided by the business or the users back into the applications, and who can go through that circle the fastest, right? So who wins that wins typically the business, right? So it's no longer the big eating the small, but it's the fast eating the slow, right? So that's the overall theme that we're operating in here. And this is a important thing, right? Take a few minutes to focus yourself. What's the challenge? What's your company doing in that regards, right? So you might just shake it off and say, yeah, that's not affecting me, right? I'm purely technology, but most of the time there is actually some kind of business relying on this stuff. So ask yourself, what is this and how can you support that, right? If you take that away from today, that's all we could achieve, right? But looking at how are these new applications, so these more user-centric oriented applications, how are they built? They are typically cloud-native applications. And what does cloud-native actually imply? So typically they're built for change, right? So with a very high frequency, you want to change them as often as possible, and you want to change them with very low risks on your production systems. And yeah, so that's one of the key things. The second is they typically run on a cloud platform, right? Because they need elasticity. They need to work on at scale, right? So, and reliability is something that needs to be put into the application, because they need to work even though the underlying infrastructure has issues or can fall apart, because the expectation from the user is actually zero downtime, right? So you don't want to have maintenance windows and the application is not available over the weekend because we're doing some maintenance on the application. That's unacceptable by most of the users or businesses. And if you're interested in how these application architectures should look like or could look like in the future, make sure to use some of the guidance and ideas from, for example, the 12-factor applications. So there is a website just focused on that, but also there is, I mean, the principles also include things like focus on APIs, stable APIs, focus on CI/CD automation, etc. So how does that application look like after all, right? I think everybody's aware of the monolithic approach, and you can we can discuss for hours about monolithic and microservices oriented architecture, but let's assume this is a monolithic application with typically a front end, several workers, and some database in the background. And the microservices approach is a little different, right? That's loosely coupled services that have stable interfaces between each other to actually provide services to the users. And if we continue a little here, and whoever has been around for more than a decade probably remembers a topic called a service-oriented architecture, SOA, right? And microservices very much remind you of these SOA principles. So it's like SOA reloaded. Basically, the focus is on faster release cycles, right? And scaling and availability, but also team independence, right? So getting stuff done, decoupling larger blocks from each other so they can actually work independently. But this requires a better understanding of distributed systems architecture, right? You cannot just take two pieces of an application and distribute them to the Americas and Europe, for example, because you need to understand the impact of latency, for example, but also the impact of decreasing availability, for example, in certain areas. So the idea is to leverage these ideas from the service-oriented architecture as well. And if you look at how things are changing or how applications are handled today, so you typically have the existing applications on the left-hand side, so you can either just maintain them and keep them as is, but most of the applications are still somehow in the works, right? So what we see typically and what we want to focus on here in this specific presentation is replatforming and refactoring. And replatforming is really just keep the application as is, but move it into a different environment, while refactoring is actually modifying the application for a new environment, right? So this is the difference between these two that you typically see. And of course, you can go all the way to the right and actually rewrite application on and develop them for the cloud, in the cloud, for example. But this typically requires a lot more effort to be put into the application, which is also typically taking a lot more time, right? If you look at the waves, as I said, the first wave is typically something like repackaging. So words like V2C, so VM to container, will come up more and more often. You might see that in Teams already, that instead of shipping an RPM file from the output of application development, they might actually produce a container or actually an image, right? So to instantiate that on a container host. And the other topic is more the whole second wave is like rewriting. So decompose the monolithic applications, differentiate between stateful and stateless services, and actually migrate that off, right? But if you look at the just some images here, so the repackaging might be very easy, right? But you also need to worry about, does that actually work? Does that work at scale? So the complexity to migrate is fairly moderate, but the complexity to migrate to the second wave and actually rewrite the application is a pretty high complexity. So how do you actually deal with that, and how do you support that? So this is where we actually introduce containers, right? So moving on to containers and a little container history, and I don't want to bore you with technology that's been introduced in the 1970s, 1980s, but just to give you an idea, right? So containers have been around for quite some time. It's not a new technology. We had it implemented on various levels, and if you look at something like, for example, VMware ThinApp in 2008, that's some kind of a container technology as well, right? So, and we could add a lot more bubbles for today because the container landscape is changing like never before. But just to give you an idea, this technology has been around for quite some time. And probably just to highlight the real basics. So typically you have an infrastructure, right? So you have your operating system, the host operating system, and then you have the Docker engine that actually runs the container, right? So just a word on Docker. Docker is, on the one hand side, a very famous open source project, right? So this is the core technology that's also embedded in Docker, the company. But just to make you aware, right, there is an open source project and there is a company. There have been a lot of name changing in the past, right? There is Moby and all kinds of kits that have become available. Just to give you an idea, right? Containers run inside an operating system typically, and they provide a process in an operating system which is isolated on the operating system level, and it abstracts the application from the underlying operating system. Right, so the benefits for containers can be broken down into various areas. So the first is, of course, the build process, and we'll see how this actually looks in a minute. So the developer can actually build the application and puts all the dependencies into an artifact or an image, right? And that image can be put on a registry, and that registry helps it to actually ship the application, for example, from the local development workstation to a production server where it's supposed to run afterwards, right? So the and this is actually one of the key benefits, right? It's like a zip file that can be executed, right? It's the whole. A colleague once called it an MSI file without the hell of DLLs. So yeah, you can actually just build it and it will run anywhere where you find actually the container engine to run it, right? So we have the build, the ship, the run, and then this results in increased velocity, right? So you can speed up the whole process instead of focusing on all kinds of dependency management and orchestration and making sure that the underlying operating system is the same. This doesn't matter that much after all, because all you need is a runtime where you can execute or instantiate your container images into containers. So how does that play together with VMs? So where do VMs and containers live in the stack, right? So if we look at the abstraction here on the left-hand side, we have physical infrastructure and operating system and applications. What virtualization did is really to abstract the hardware for virtual machines, right? So we're decoupling the operating system from the underlying infrastructure, and probably everybody on this call is aware of that. So what do containers do, right? Containers introduce the operating system abstraction with small pieces of the operating system living inside the container, but the rest is being decoupled from the underlying operating system, right? And logically, you would run that just to make the runtime as easy as possible to also put that in a virtual machine and actually use the existing hardware abstraction, because hardware management at scale is actually pretty complicated. So make sure to leverage what you built before, because it's just a different thing inside the operating system that we're working on. So looking at traditional applications inside VMs, right? So we do have a Linux kernel, for example, a standard Linux host. You have your common Linux kernel. You have your management and user space tools, right? So all kinds of libraries and management softwares. And then on top, on top of that bundle, you actually create your templates your VM templates, your Linux templates, for example, and then you put your application software in it and configuration by using configuration management tools, all kinds of distributions, and you update and actually manage your packages, install your middleware, etc. Right? And then it instantiates the actual application processes and runs them for you, right? The challenge with that is it's typically a very long-lived operating system, so you need to worry about all these topics that I just mentioned, right? So the patching, the image updates, but also the configuration drift, which is another key issue, right? But that also creates quite a configuration management overhead if you look at, you just want to run a certain application process, right? So you don't actually need the underlying operating system. It's just a helper to actually get the job done. But in essence, you don't want to run the operating system for operating system purpose. You want to run the operating system for the application, and all you need is actually the application. And this is where a Docker becomes, or containers actually become very interesting, right? Because if you look at the at a container host, right, running the Docker engine, so there is a Linux, there is a it's Photon OS. It's a very small Linux system. Just for illustration purposes, you could have any other system here. So all you need to do here is actually do Docker run container image, and what happens is you actually instantiate an application from that image into a running container, right? And how does the container look? So we do have a Docker file, and that Docker file actually includes everything that you need to have, just double clicking on that, everything that you need to have to describe the application, right? So what's the foundation for the actual container, right? So in this case, it's Ubuntu, but then going into what is actually being executed. So this is Apache, right? So this is the topic that's being focused on here. And that's all that's being instantiated based on the Docker file. And so the container will run on that container host in the way you describe it, right? And if you have a second container, for example, instantiating WordPress based on a Red Hat system, for example, that's also possible described in the Docker file, right? So you might wonder, where does this actually live, right? So how does the container image get deployed to the container engine or the Docker host, right? So what happens is when you do the Docker run container image, it will look for an image cache. Does that actually exist locally? And if not, it will go and query, for example, Docker Hub, if you specify that as a Docker as a registry. So it will just look for the container image there and actually grab the image and execute it for you. And it will run on the system, and you can instantiate that multiple times, of course. On the other hand, you can also have a private registry, right? So you might not want to put your business applications onto the public Docker Hub, or for example, the bandwidth reasons, right? So those containers can create quite a bandwidth on your public-facing network. You might want to have a private registry for security reasons as well, and then you can just put that locally and just query a different registry, right? Instead of going to the public one, you can go, for example, to the local one. In this case, Harbor. It's included in vSphere integrated containers, one of the container products that VMware is shipping today. So that's just for your illustration how that actually works. I'll hand over to Michael now for a quick demo.
Before we go into the demo, I would have a quick question, if you don't mind.
Sure. Go ahead.
So since containers are supposed to be very short-lived virtual machine, well, not virtual machines, right, but applications, once you stop the container, basically its contents are gone. So how do you actually persist storage then? If you have a database, for example, right, and there is Postgres, MySQL containers out there, so how would that work in the backend?
Bjorn, shall I take this?
Yeah, go ahead. I think you can just take it and probably even talk about it in the demo briefly.
Yeah, so that's actually a good question, because first of all, most of the applications being migrated, as Bjorn mentioned in the re-platform, repackage, are usually the stateless, easy ones, the user-facing web services. And nowadays we see platforms like Kubernetes and Docker also moving into a world where they support stateful or have better support for stateful applications. And this is not like an easy task, because containers are meant to be ephemeral, so they should come and go and start, especially in a cluster. They could start on one host and be restarted on another host. And you also have the kind of story with cluster file systems that you might want to use in those scenarios, and that's a very tricky task to be solved and addressed. And all the container orchestrators that we're going to mention later in the presentation, and also in the Kubernetes specific area, they all have support for stateful applications, but they differ in the way as they do it. And now we see a more kind of a standard emerging with the container storage interface, the CSI, where the community is going to settle down on the standardization, how to plug in and hook in different storage backends, be it NFS, be it iSCSI, and so on. So long story short, stateful applications are still kind of tricky to get right. Most of the platforms have support for them, but kind of the difficult parts are still in the details and have to be worked out.
Okay, perfect. Thank you.
Good. So just a quick demo, and this is like the Docker 101 basic demo, maybe most of the people already have seen, but we have still chosen to show this just to make it clear and circle back to what Bjorn said in the beginning, going fast into this circle and cycle and going up fast. And we have customers saying to us that they can spin up virtual machines in 2 or 3 minutes and they're up and running. So why the heck would a container be even beneficial in this area? So there are different kind of advantages of running containers. Oops, sorry. Let's just quickly jump in here. And the most important advantage of a container, at least from my perspective, is that you give control to the developers when it comes to describing the environment the application has to be run or be spun up. Usually we had to send over between developers and operators, and developers specify, I want this PHP version and the Apache and things like that, and they were running a different one locally on the local devices, and in production they were running a different version of PHP or Java, and then the issues, the trouble became apparent because of configuration drift. Now with containers, and speaking about Docker in particular, we have this infrastructure as code syntax or file or power that we give to the developer, where he is going to specify the runtime for his application. And Docker in particular made it very easy to leverage all the functionality that has been in the Linux kernel for a very long time to make containers work, like the isolation and the resource sharing or resource isolation that Bjorn mentioned with C groups and namespaces. But Docker made it easy to use and put it in a nice tooling that everybody can easily understand and use, and then deploy to a registry, and from there on consume and so on. So we'll start with the Docker file, and Bjorn showed one, but this is another one, which is a pretty basic one. It says from scratch. It means that there's no base file system or base image that we're going to build on. Usually you would see something like Ubuntu or something like that. This is when you deploy an application that has a dependency onto specific libraries or stuff that has been provided by the environment. Now, since we are going to deploy a Golang application, which is a statically compiled binary, we actually don't really need a base file system, because all the dependencies are shipped with the binary. So that's why we say from scratch, and this is also pretty nice, because it gives us a very slim image. If you would specify from Ubuntu something like that, you would end up with a 70 or 80 megabyte image, because this is going to be pulled down. And Docker again made it very easy to use a layered file system syntax that you can reuse existing layers like a base layer, and then add on top of it a Java JRE layer, and then top on this, deploy your jar file or whatever. So this is the image sharing that Bjorn mentioned in the registry part. Now, second, our line 3 and 4 is basically just saying add some stuff that's in the local file system we're going to see right now, add this folder, add this binary, this is just a web server, and then expose the port 40,000 to the outside world. This goes into Docker networking, which we don't have time today to explain, but essentially if you run multiple containers of the same application, for example, which happens to use the same port. For example, this application uses port 40,000. You have to make sure that on the exposed side of the Docker network interface, you use different ports, because otherwise you run into port conflicts. But in this case, we're just. Is there a question?
No, the good thing is, even though we don't have time today, in 2 weeks' time, Yves is going to take us through the intrinsities of...
Oh, right. Oh, that's a good hint. That's a very good hint. Yes, Yves is going to be like the godfather of networking. That's right. And then we specify the entry point, which is the web server. So this is the Docker file. And based on this Docker file and the the source code that we have here, which is this application, and which is our folder for some web data, like an image, I think is in there, we can start and build our container image, from this Docker file syntax. And this is something that we do manually here in the demo, but usually you run through a pipeline, which is the continuous integration, continuous delivery, a part that Bjorn mentioned before. So the developer would upload the source code into a source code repository like GitHub. From there, Jenkins or a build system would see, oh, there's a new kind of commit that happened into this source code repository. Now I'm going to start to build the binary. The binary is going to be built, and then from this on, the Docker file is being pulled and the Docker image is being built. And so this is a fully automated process that's happening on a regular base, or perhaps even per check-in, per commit from the development team. And what it ends up doing is it's just basically doing the a build and an image in this case. So I created a makefile just to make it easy. And now my system is going to build from the source code the binary, and it's building it in Linux because I'm running the Docker environment on Linux. Then the Docker process kicked in, and it built a Docker image, which is this name. I don't use a version tag. Usually in production you use version tags. I just use latest. And in the local cache on my machine, you see a new image. It says it's 35 minutes ago because I built it 35 minutes ago, and it just saw that it's the same, so it didn't rebuild it. And the size is 6 megabytes. So it's pretty slim. It's a web server. And now we can just spin this up. And we specify remove this container when it exits, run it interactively, so I get this nice output. Do a port mapping for the port 40,000, which is on the container side, and map it to an outside port on my machine on 40,000 as well. Limited by CPUs, so just give it half a CPU of my machine. Just give it 50 megabytes of memory, and I used these limits, or I set these limits just to show that with this tooling, Docker made it very easy again to leverage the C groups kernel features that have been in the Linux kernel for I think more than 10 years now, just by specifying some command line flags, which is very easy to use. And on the right hand side here, there's just a container monitor. You see that the container is already running. It's got this name, it's got this ID. It's currently doing no CPU, and it's being limited by 50 megabytes of memory. Now we can go to my local machine, just check the port 40,000, and you see that the web server is running. If I stop this thing, the container is gone, and the website is also gone as well. So just what we wanted to show, and this is again the very easy Docker 101. It's very easy to build, to give first of all power to the developer to build the application, including all the dependencies and specifying how this application should be exposed to the outside world, like port mapping. You could also specify volumes to the question that you had, Frank, about persistent storage. You could say that this application needs some kind of volumes where it's going to persist the data inside. And then the container gets stored somewhere. Here I put it just on my local machine, but it could also have uploaded it to a Docker registry. And from then Docker run would pull it or use the cache and execute it. And you can also specify limits. And this isolation is pretty powerful. So I could spin up like 10 of these on the same machine, which would not interfere with each other. And then also we could limit them by resource usage and control them. Now the question is, I could also do this with a virtual machine. So what's the advantage of like spinning this up in 2 seconds versus 2 minutes if you're good with spinning up virtual machines? Now imagine that for each application that you spin up, you have to spin up a separate virtual machine because the application is a PHP or Java application that used to have some specific libraries or requirements or configuration settings. So for every unit of this application, you would have to spin up a new virtual machine because otherwise they would interfere with each other or libraries would conflict. With containers, because they each live in their own namespace or namespaces, you could spin up different kind of Python, Java, PHP applications with different libraries on the same machine. And since they are isolated on the operating system level, you don't have those conflicts from a library perspective. And by this, you can also drive utilization on the virtual machine or on the host, because now you can pack more processes inside the same operating system, which was not possible before on virtual machines or on other hosts, because they would directly see each other and interfere with each other. So I hope this made sense. Bjorn, Frank, any comments on this? I mean, it's just a basic demo, but any comments so far? Questions?
I keep being impressed by how small you can go with Go, the language, right, or Golang. So 6 megabyte web server. Oh my goodness.
Oh yeah, good point. Yeah, so you would spin up Apache usually and bring in some other stuff also just to bring up a website, like a front-end site. And with Go, you can statically compile this all into one binary. You don't need Apache because the web server is in the binary, and you can go pretty small in size. That's right.
Also from an attack surface perspective, right? Instead of patching your Apaches with all the vulnerabilities, you have a 6 megabyte thing that's already compiled. It's amazing.
Exactly.
Anyway.
Just the kernel, just the operating system, and you're good to go. So back to the presentation and moving on a little bit. So we've seen what containers can do. You can go pretty fast. You can give power to the developers. You can isolate them. You can drive utilization, sharing, and all this stuff. Now, just running one container or multiple containers on the same host basically is not really that much of production readiness or readiness that we are used to. Usually, we would run our application replicated in a cluster. So from this one host with my Docker environment or with my container runtime, we easily end up in production with multiple hosts. And these multiple hosts have to be managed somehow. And this is where container orchestrators come in, like Kubernetes, which we are going to cover in this presentation, but also in the next two parts more deeper. So container orchestration, there's a lot of things orchestrators currently do, and there's a kind of big difference between what some of the like container orchestrators do, which are more focused on cluster management. Then we have more kind of operating system stuff with monitoring and logging. So there's a huge grade between container orchestration when you compare Docker Swarm, Nomad, Kubernetes, Mesos, and so on. But most of them implement some of the features that we see here on this page, which is of course scheduling, so deciding where a container is being put with affinity, anti-affinity rules, replicating those images that if one host fails, the other ones still survive, or restarting them, doing rolling upgrades with zero downtimes, finding other services, which means that if containers come and go, they get different ports, they get different IP addresses. So how do they find each other? So you need a stable name service. Most of them bring service discovery with them. Storage management, as Frank already asked about, is a big topic today, just to get this right. Networking, obviously, which is Eve's part in this third part of this tutorial, and some operational stuff around this. Some of them you already might know, like Docker Swarm, which is a Docker just for the clustering, which is also easy to use. So Docker, again, made it very, very easy to stand up a cluster and run containers in a production and replicated environment. Kubernetes kind of currently leads the path in terms of community contributions and awareness, and backed by Google, being a very sophisticated product already right from the beginning, because Google put in 10 years of experience, of own experiences running own container cluster management, and before they open sourced or created Kubernetes and then open sourced it. Marathon is a container orchestrator which uses Apache Mesas. So this is kind of a different style of container orchestration. It's a two-level approach, so to say. We're going to cover on the next part of the series. Nomad from HashiCorp, very slick, very lightweight. Not that many features like Kubernetes, but actually a very good tool if you want to go quick and fast with container orchestration, but also VMware vSphere integrated containers, which kind of has a different approach to it, to handling containers, but also falls in this category because you spin up containers, and vSphere integrated containers is going to manage them at a production and cluster scale. At the end of the day, all of them give you a framework to deploy scalable, robust, and efficient distributed systems. So you write, the application owner or developers, they write distributed systems, and they're going to be deployed and run by those container orchestrators. Just a short preview. Again, this is what we're going to cover in the second tutorial, the second part, much more deeper. So usually you have these master components, which have their resource scheduling and resource management. You have a meta store, which is usually etcd or console, where the state is persisted in terms of information, where each node is running and where each container is being spin up and stuff like that. So it's like the backend state for the whole container orchestrator. And then you have the agents, which are the workhorses which run a container runtime. This could be Docker. Kubernetes by default uses Docker. Swarm obviously uses Docker as an engine, but doesn't have to be Docker as a runtime, could be another container runtime. For example, Mesos uses its own containerizer. Now, since this is a tutorial on Kubernetes, or a vBrownBag series on Kubernetes, 2 more words on Kubernetes itself. Kubernetes was born by Google and goes back to the experience of running container cluster management inside Google for more than a decade. And there's a book already in the second revision now, which is called The Data Center as a Computer. And the idea was that most people think about container orchestration just as a cluster that spins up or runs containers. But the idea is more that treat your data center or your cloud resources or the fleet of machines that you have just as a giant single computer, like a computer that you have on your desk, but much bigger and at a global scale. And this means you should think more about this as a system, like an operating system that you interact with, that provides you with abstractions like storage management, network management, that you don't have to think about it when you write your application. You just create your application, write your container image, specify the way it should be deployed, like 5 replicas, and be exposed to the outside world, and then you put it into this big machine, and the big machine will take over for you. So this is different from what we usually do, what we have done in the past, which is kind of an imperative style. You describe each step that your package goes until production. It's a very imperative way, and instead with these kinds of systems, especially Kubernetes, you just say, here's my application, run it 5 times for me, somewhere replicate it, make it available, make it exposed to the outside world. I don't care how. This is kind of the pivotal mantra. Run it in the cloud for me. I don't care how. Kind of similar. It should be seen as an operating system, and the operating system then will run this for you. Think of yourself, if you have a Windows machine or whatever, if you start a machine, if you start an application, the operating system just won't ask you, where should I run it on? Which core of your machine, of this machine, should I run it, and how should I isolate it, and which network port should I open it for you? The operating system handles this for you, and the same is true for these kind of cluster managers. So this is what we already said. Kubernetes is an open source system for deployment, scaling, and management of containerized application. But more importantly, again, it should be seen as an operating system for the data center or for the cloud, because it's also supported in AWS, Google Cloud Engine, or Azure. But also on premise, like if you have an infrastructure as a service environment like vSphere, you can deploy Kubernetes on this infrastructure, obviously. So Kubernetes requires infrastructure, so it doesn't replace virtualization. Some people think it replaces like hypervisors. It does not. It requires you to provide an infrastructure as a service layer, and then it settles on top of this and exposes an API, and then you run applications on top of this. Just a short teaser. We'll get back to this in the second part of this tutorial in much more detail. And now I'm going to hand it over to you to the last part of this presentation, VMware strategy and solution. To Bjorn.
Sure. So thanks for that, Michael, and everybody that has listened in so far. So I just want to encourage you to listen in next week. So Michael is one of the major Kubernetes experts inside VMware, and you will always learn something new from every presentation. So just make sure you tune in next week or get the recording up. So the
Thank you.
Oh yeah, sure. You know I'm a fanboy. So the next piece of the presentation is really just to give you a very much cloud native applications portfolio in a nutshell. So you probably have heard about vSphere integrated containers from last year's VMworld, and you have probably tested that out already locally. We just shipped a new version, which is vSphere integrated containers 1.2, and in addition to running containers as VMs on vSphere, that's again, right? Containers as VMs on vSphere. You can now even run native Docker container hosts on vSphere through vSphere integrated containers, right? So we added a second option to the product because, as Michael said, we do have the virtual container hosts inside vSphere integrated containers that have an opinionated way of actually making use of vSphere resources, right? So it will scale within the boundaries of your vSphere cluster, or it will scale within the boundaries of the specified resource pool that you provide to the virtual container host, so the VCH, right? This is the VMware native form of running it, but sometimes you want to leverage some of the features inside Docker. You want to have, for example, swarm capabilities, and this can be done with the newly integrated Docker container hosts, right? So while we take care of some of the swarm functionality inside the virtual container hosts and actually run the containers at the vSphere scale, the Docker container host will allow you to natively interact with Docker. So that's a great use case for a developer sandbox, for example. So you need to have full exposure of the Docker features in the development lifecycle or in a testing cycle, for example, while reworking your applications and actually making them just put them in a container, for example, or actually building applications from scratch in containers. So this is a great offer to the developer community from the platforms team. So these are the two capabilities that we ship with vSphere integrated containers today. In addition, as I mentioned before, there is Harbor or Project Harbor, which is all open source, by the way. Everything that I've mentioned here is now all open source. So Project Harbor is actually the registry, and then we have another project which is called Admiral, and this is the actual container management system, a user interface. It actually has rights and roles attached to it, so it integrates with vCenter, so it allows you to make that leap into the future of applications. So actually refactoring existing, replatforming existing applications into containers. So the whole V2C capabilities is everything that you're looking for. You will find that in vSphere integrated containers, right? So if you haven't checked it out yet, it's a feature of vSphere. It's included in many vSphere editions already. So I just remember Enterprise Plus. I'm not sure if there's anything else, but this is it's a great technology. It leverages everything underneath that you have in place already, so you don't need to worry about most of the stuff. So especially when it comes to stateful storage, right? You will be able to use everything from a storage technology perspective that you already have attached to your vSphere platform. You don't need to worry about integrating specific hardware into a new bare metal system, for example, just to run your Docker containers, right? So you can reuse that and make use of the whole vSphere platform and the benefits that you are operating in already today. In addition, we launched something called VMware Pivotal Container Service at VMware in Las Vegas and also in Barcelona this year. So Pivotal Container Service, in a nutshell, really allows you to deploy an enterprise Kubernetes distribution on top of vSphere, right? So we have seen a lot of demand for that, and people want to run Kubernetes, but it's not just about setting up or finding an easy way to set up Kubernetes cluster. This is one thing that a PKS or Pivotal Container Service actually does. But it will also allow you to make the whole day two operations. So everything from scaling your Kubernetes infrastructure, adding more workers, for example, adding more masters, but also upgrading your clusters and the whole repairing of failed nodes inside your Kubernetes cluster. This will all be automatically done by a component called Bosch, and Bosch is actually the operating tool that is being leveraged for PKS, but it's also being used for a technology called Cloud Foundry. So this is like a common operating mechanism to make life easier for the platform engineer that we're going to mention in just a few minutes. So the person that's actually providing all these kind of frameworks on top of the infrastructure and making sure the application developers are getting what they need. And you'll understand that in a second, right? So this was the high level overview of the core technologies. I could talk about that for way longer, believe me, just for the interest of time and keeping it short and crisp here. These are the core technologies. We do have a couple of other things in the portfolio from our brothers and sisters at Pivotal. So Pivotal Cloud Foundry, for example, it's another technology. And you can, of course, run any other technology on top of vSphere, but these are the ones that actually come from VMware. So why is it important, and why do we want to stress the whole role of the platform engineer? Because if you look at the overall cloud native landscape for now, and this is a slide taken from the Cloud Native Computing Foundation, which is open source, so you can find that at the GitHub URL in the bottom of this page. So this is just a rough structure of where the landscape actually is right now. So you do have the public clouds, you do have your infrastructure there, but you also have all kinds of provisioning software. You have your runtimes, your orchestration and management, you have your application definition and development, and then all kinds of integrated platforms and other technology on this slide. And it's just an overview, right? This is what's out there and what developers might be using, right? So the projects that are being highlighted here are the projects that are hosted by the Cloud Native Computing Foundation, and the most prominent one is probably Kubernetes for now. And yeah, so this has been donated to this foundation to continue working on it in a joint fashion, right? And so VMware is a platinum member of this foundation. Same applies to Pivotal, and there are many others on that foundation jointly working on this standard to make sure that you have a holistic and seamless experience for the developers, right? So who's going to take care of that, right? So do you let the developers run with that and then it will magically run somewhere, or so who's actually taking care of that, right? Because just from an approach, so no, too far. Okay, so if you look at the outer layer, so the hardware, then you have typically some kind of infrastructure as a service component, then you have your container orchestrator, or you even go into an application platform. And So the bigger the bubble at the bottom, the higher your flexibility and less enforcement of standards you will find, right? But the closer you go to the top, so the application platform, the lower is your development complexity, and you will have a lot of operational efficiency because it's so standardized, right? But it will also limit some of the capabilities for the developer, so you won't have all the freedom, right? But the overall idea should always be to move workloads to the top of this, right? Instead of building everything on your own, or let the application developer focus on so many small areas that don't provide real benefit to the application or to the business, right? Let them focus on what actually creates the difference for the business, right? And this is something that I mentioned in the beginning, right? So you don't want to build application platforms just for the hell of it, right? You want to build the application and the underlying platform to get stuff done for the business, right? That's the overall idea. And so if somebody's going to say, like, we're going to run this Kubernetes thing now, who is supposed to do that, right? And I would argue, and that's why Michael and I are putting this into this presentation, is actually we think it should be some kind of platform engineer, and that platform engineer is sitting somewhere in between IT operations and the developer space, right? So that's the person that helps to translate the needs of the developers into IT operations terms, and IT operations will be able to provide more services into the development community to actually evolve that kind of conversation, right? And right now, the hot new thing is Kubernetes, and last year it was Docker, right? And there will be other technologies following, but there needs to be somebody inside the company that actually focuses on helping enable the developers to run that on the private cloud, but also on the hybrid cloud, or finding the right place to actually run it, to not just have it running somewhere, but also making sure that it's properly secured, right? You don't have any leakage or issues, right? Because if you build an application from scratch and you run it somewhere, anything can happen, right? And we want to have agility and use all these new technologies and the services that are out there, but at least somebody needs to worry about how is it actually run, and is it secure enough, right? Okay, so that's the big piece for us today. I think we'll just finish up with a quick preview on what to expect next week in the vBrownBag series here, and I'll just hand it over back to Michael, and I just want to say thank you already, and take it away, Michael.
Yeah, just a quick preview on next week. And since I don't have the slide deck done yet, just feel free to ping me on Twitter or on the chat window if you have specific needs or questions that I should be answering next week. But otherwise, I'm going to focus on, again, container scheduling and management. So this stuff that we just very briefly touched today, going more deeper inside Kubernetes and how things are working inside Kubernetes, as well as show the zero downtime approach, because this is one of the benefits that obviously developers want and love in these days, and some kind of the fancy auto-scaling system with Kubernetes, self-healing, self-auto-scaling, self-aware applications. All right, this is it for me for this week. Also, thanks again to you for listening. Thanks for Frank for setting this up, this series, and I'm going to hand it back to Frank now.
Yeah, thank you guys very much for actually presenting. If you have any questions, feel free to pop them into the chat. I think the guys don't have any issues hanging around for a few more minutes to actually answer those questions.
No, that's good.
If you wouldn't mind actually opening up a web browser in private window or something like that, Michael, I just want to point folks to a very good resource to actually get started. Normal labs.hol.vmware.com, our hands-on labs.
What did I type wrong? Labs today. Oh.
Yeah, labs.hol.vmware.com.
I missed the VMware. I'm a regular user of this platform.
Yes. And I'm a huge fan of it as well because not everybody can afford lab gear or licenses for it. So a platform like this actually allows you to get your hands dirty with new technology where a home lab wouldn't meet the Wi-Fi acceptance factor. If you click on all labs on the left-hand side, or yeah, the cloud native applications one, we actually do have a predefined filter. And especially the 1830 and 1831, they were revamped for at VMworld, so they should be running the latest and greatest. Maybe not the VIC 1.2 release just yet, but again, I'm a huge fan of the VMware hands-on labs because they allow you to tinker and play around with it. You don't have to actually follow the lab manual. You can just branch out and use the environment and for the needs that you have to familiarize yourself with new technology as well. So they are a great starting point to actually start to repeat a similar thing which Michael did during the live demo today.
Good point, Frank.
Yeah. And we do have one question. Oh no, yeah, just a comment. Awesome presentation. So I'll happily relay that. Yeah. Okay, perfect.
Thank you very much.
Thank you very much, guys. And I look forward on seeing you next week again for a Kubernetes deep dive.
Yes.
Also, since it comes up with my customers quite often on a regular basis, if you wouldn't mind adding a small, how do I actually monitor my orchestrated containers to that as well? Because I know Kubernetes has some basic functionality there. I think that would be really interesting for folks.
What do you mean by monitoring? So logs?
Logs as well as utilization, to make sure that your environment is actually healthy.
Yeah. I cannot show Wavefront next week. I think Bjorn just
I could.
That's right.
That's fine.
Yes, I can show the some of the primitives of Kubernetes. Yes.
Yeah. Just to give folks a few pointers, right? Because once you start deploying it, I think that's a very, very important part of the actual operations as well.
Yes, just took a note for it.
Brilliant.
Good. Awesome.
Thanks again. And yeah, have a nice day.
Thank you, guys.
Thank you. Bye-bye.
Thank you. See you next week. Bye-bye.